Hello, I'm Dr. Richard Sapienza, and I want to welcome you to an Energime University brief. We'll be talking today a little bit about solar thermal technology, but I really want you to know about Energime University. We are developing low-cost energy solutions for solar, wind, hydro, and biomass. And what we're also doing is we're trying to teach the world about how to use energy solutions to these important aspects of our lives and to these important aspects to our planet. In general, Energime wants to teach you and also show you that sometimes a relatively simple approach where you learn from those who have gone before us, improve, and then prove it in the real world is the best way to approach changes and improvements in our world today. Now, you might have wondered, who the hell am I? Well, I'm the former head of Brookhaven National Laboratory's Energy Utilization Division. I'm a holder of about 40 patents, and basically a former small business owner who's your guide today. And I want to welcome you and show you what it could be like for you in taking a Energime University course, and in why you should join and be part of the Energime experience. Now, like I said, we'll be talking about solar thermal today. Now, solar thermal is just basically the sun's heat. That warmth you feel when you go out on a nice sunny day. What happens to your car in the summertime when it gets all hot inside? You know that somehow the sun has heated up and warmed up your car so it's much hotter than it was outside. So the sun must have been putting in some energy into your automobile. Well, if you look at the way you could use solar energy, that way, where we heat up something like the car, is solar thermal. Now, most of you are probably familiar with photovoltaic collectors, so-called PV, photovoltaic. What they do is they take the sun's light and they convert it into electricity. And that electricity is something usually much easier to understand for people than talking about heat. But we have a greater interest in solar thermal collectors because it is an extremely useful form of solar energy. Now, if you look at why we're more interested in thermal versus photovoltaics, it's mainly because of the efficiency differences between thermal systems and photovoltaic systems. There's a lot more energy that can be accumulated and out of a thermal system than you can out of a photovoltaic system. Now, the benefits of solar thermal are all over the place. They are important to us as a country, important to us as a world. But if we really look at all of the things and all of the benefits of solar thermal, what we'll see is there's certain technology elements needed to take advantage of these benefits. Now, what we would do in the course is we would go over the aspects of solar thermal, why there are these kinds of benefits, and what are the kinds of problems that's there. But for you today, I want you to see just one part of this slide, is that the collector is the most expensive item. And that is where Energime focused its attention, to make solar affordable. That was the challenge, and that's what we worked upon. And we did this by studying what was in the literature, what was understood about solar collectors, the kinds of things that we would offer to you in an Energime University course, and then taking those understandings and converting them into a product that makes sense for the world today. Now, what we did in our concept was we focused, and that's what this funny little diagram is, of what are the key aspects of a solar collector. And if you just think to yourself, you may even come up with the same thought. It is to have a low-cost mirror arrangement, something that was low-cost, simple to use. We needed units that were not too sophisticated, too precise, or too expensive. The goal wasn't to get 100% of the sun that's coming in. The goal was to have something that was usable by the masses, something that had market appeal, and that could stimulate the use of thermal power as a practical choice by it being able to be interacting with other technologies that are out there. That technology interface potential is one of the key things behind any development that companies make. Now, it turns out what we try to do in our system is to look at what are the best and the worst things about the three types of common solar concentrators that are in use today. Now again, in a course, we'll teach you about each of these individual units, the parabolic trough and what its advantages and disadvantages are, a central receiver station, where typically this is where you generate electricity using flat mirrors, and a parabolic dish concentrator. These extremely high power units and high cost. Now each of these, like I said, has many attributes, but we wanted to take those attributes and put it into a system that avoided the weakness of each of these. And so that's what we did. We took the simplicity of the trough, the reflectivity of the flat mirror, and the concentrating power and shape of the disk. Now, we used, as I said, a flat front mirror surface. One of the other things we'll cover in the course is different aspects of mirrors and why you want a front surface versus a non-front surface, why you want a flat over a curved mirror. These kinds of things right now are not always fully understood, and we would try to cover those in a course. Now, one of the things that I do want to point out here is that typically you have a silvered background on a mirror with a glass over the top. Well, that glass over the top, not only does it absorb some of the energy that's coming in, but it also refracts it. It bends it ever so slightly. And so these types of things to the glass mean changes to the type of unit that you might want to use and losses in your unit. Okay? We also want a very smooth surface because otherwise you get what's called diffuse reflectance. That's throwing the light all over the place. Diffuse reflectance can be so much that you don't even see the light because it's so tiny, the reflections. And we'll actually talk about diffuse reflectance as an important aspect of trapping light, where the surface looks absolutely black. What we'd like is what is called specular reflection, the perfect reflection which comes right off of a flat surface and a front surface. And these are some of the thermal losses that you typically find in mirrors that we've tried to avoid. We'll also talk in the course about solar energy variation. You know, variation between place to place, time to time, season to season. This is important so that you can better understand what you can really get out of, example, a solar thermal or even a solar PV system. These seasonal variations, irradiation on a specific surface, as in Greenville, Maryland here, where cloudy versus a clear day, and an example of the amount of normal insolation, that's a fancy word for the amount of sunlight that came down and that was usable for a certain location. And here we see it for Cairo, Egypt. And we'll show you how you can use the data that's online in both the internet as well as in books that you can find for your advantage to be able to figure out what solar will do in your area and what solar choices that you can make for your location. Now, we'll also talk about tracking, okay? Now, what tracking means is we know that the sun moves across the sky. It goes from sunrise, to sunset. Well, there's a big performance difference between tracking systems and a fixed system. Now, what that means is a tracking system just follows that sun. This simple little diagram here shows you a typical tracking difference. Without tracking, this is the red blocks. With tracking, are the green blocks. The green added, obviously, to the red, so that the overall energy collected under tracking can be significant. It can be more than 35% than a fixed system. Remember, all PV systems tend to be fixed. Now, what we wanted was a solar concentrator design that, based upon